Thank you. So we're going to start with calculating normal probabilities, just a continuation of what we did before. We'll look at this word problem. This word problem is to guide you to do from question 5 and above in the worksheet. We've been able to do number 1 to 4 now, so well done. So let's listen to the explanation. After that, we will look at how to use technology to calculate normal distribution. The idea is this. If you have your normal curve, we all know the center is the mean. Then you have in symmetric forms, mean minus standard deviation, then mean minus twice standard deviation, and so on. So mean plus twice sigma, mean minus twice sigma. So this is what you have done so far. So, what is that value, one standard deviation above the mean? You've been able to use this picture. So basically, if this value is 4 and the standard deviation is, say, 2, then this is 6 and this is 8 and this is 2 and this is 0. So it is easy with the fact that you know the percentage here is about 34%. It is easy when the question says what is the probability that the random variable assume a value between 2 and 6 to say that, oh, that must be 68%. It is easy to say that because you are considering these two regions. Now, what if the question is probability that the random variable assume a value within 1.5 and maybe 1.8? Okay, so here it will not be so obvious what the percentages will be. Understand? So which is why we need to also use the calculator. So the first example to be shown is a word problem. After this, there will be subsequent example about the use of calculator. You will be able to do some practical demonstration with a calculator yourself in the class. Then we move to Z-score. Unfortunately, I plan to complete everything today, but I might have to do the last part, which is the normal quantile, because I need you to actually practice the Z-score also in the class. Then we can, share ideas while practicing in the class. But I can assure you, everything ends tomorrow. Okay, so let's listen to this.
In this example, the chest measurements of are normally distributed with mean 95. In this example, the chest measurements of rugby players are normally distributed with mean 95 centimeters and standard deviation 8 centimeters. We sketch the distribution curve for this data, and we label the mean and each standard deviation away from the mean. In the last example, we found the proportion of a normally distributed population in certain intervals. In part A, we want to find the number of rugby players we would expect to have a chest measurement between 87 and 111 centimeters. We start by finding the percentage of players in this interval. 87 centimeters is 1 standard deviation below the mean. 111 centimeters is 2 standard deviations above the mean. So, the percentage of players with chest measurements between 87 and 111 centimeters is 81.85%. The number of players we expect to be in this interval is 81.85% of the total number of players we are considering. In this case, 81.85% of 200 is about 164. We give our answer as an integer because it only makes sense to talk about a whole number of rugby players. In part B, we are given a percentage or proportion of the distribution and need to find the corresponding interval. In this case, we need to find the chest measurement K, which 16% of the players will be less than. We are therefore looking at the lower tail of the distribution with the value K as the upper end point of the interval. We add percentages from the left side of the curve, keeping a running total. Approximately 16% of measurements lie more than 1 standard deviation below the mean. K is therefore 1 standard deviation below the mean, or 87 centimeters.
Does that make sense? So this is particularly essential for your number 5, which some of you have done already. Okay, so you can look at your worksheet later, and that will help you complete the rest as well. Now let's move on because of our time. We will also use technology. So these are the calculator instructions for the current format that you have. And if you are using the type that I just gave to, okay, with Verna, so this is the manual. I want to believe it's the same. It's the same, okay? So I think it's actually the same. So let's use this. If Verna is not able to get it, then I'll show you the other one, because everyone is going to rely on this one, right? Okay, so suppose X is normally distributed with mean 40 and standard deviation 10. To find the probability that the value of X lies between 37 and 48, please use that instruction and make sure you get 0.406. Signify once you are done. Done? 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 Venom? Everybody? Okay. So with that, so for the new version, you see the only difference is the format. 9860 and CG50. Okay? But it's still the same thing if you notice. Okay? With that, before we calculate at all, before we play the example, can I ask you to do the following? A random variable X with mean 40 standard deviation 10. Find this probability.
The first probability. Oh, it's not one.
First one is the same one as the one.
That's the one you just did? Yeah. All right, so try the other two.
Lower.
So hopefully your calculator has cumulative probability there. If it doesn't have, then we're in trouble.
So we're trying B.
Yeah, what do you do for lower
Where are we trying?
Yeah.
What do you say?
What do you put for lower?
What's the lower value?
X is bigger.
No, but this is bigger than 45. So the lower bound should be a 45.
That was the upper
I
bound.
just can't read.
The upper bound?
1 million. I think we just make it a really we can't just make it a really big number because it goes on and on.
Yeah, wait, what's the just a variable? This is a lot.
Upper bound.
200.
That's it. Just put a very big number.
I think you have to use the inverse because the tail left is lower.
No, use a very big number.
Is there?
Okay, look at this. Look at this. Use a very big number. Look
Oh, yeah, they actually do that.
here.
Oh.
Oh.
Use a very big number because it's infinite. Remember,
Oh,
the number curve is between negative infinity to positive infinity. Guys, remember this?
Has to be net.
Okay, remember this. So just use something extremely high or low. That's why 1 times 10 raised by 99 was used. That's like 10 raised by 99. That's a very huge number. Okay? So just use a very big number for lower and upper. Of course, this is not the end, but others are like negligible. Like it's not so significant because it's going to be a bunch of 0.000005 away. You get my point? So just make use of this. I want to believe maybe this is like the maximum memory the computer can accommodate. Maybe that's why it is 1 raised to power.
Put another 9.
10 raised by 99. It's going to be error maybe? Maybe the memory. All right. So did you get this? Oh, okay. Look. I actually didn't say this. We use a high value such as this to represent the upper bound. So yes. Done? Okay. So let's play this. Probably there will be some new information from the audio part. Okay? You might just gain 1 or 2 things from the audio part. So let's play this.
A normal distribution is completely described by its mean and standard deviation. We have seen that there is a fixed proportion of the population which lies in an interval, depending on how many standard deviations the endpoints of the interval are from the mean. If we are dealing with whole numbers of standard deviations from the mean, we can use the proportions already studied. However, for other intervals, we use technology to calculate the proportion. In this example, a normally distributed variable x has mean 40 and standard deviation 10. In part A, we want to find the probability that x is between 37 and 48. These numbers are not whole numbers of standard deviations from the mean. You could calculate this probability using a definite integral to find the area under the normal curve. However, because the normal distribution is so important, there are special functions on your calculator for calculating normal probabilities. We set the lower bound to 37 and upper bound to 48. The probability that the variable lies in this interval is about 0.406. In part B, we want to find the probability that x is greater than 45. Again, this is not a whole number of standard deviations from the mean. We set the lower bound to 45. We want the upper bound to be infinite, but our calculator cannot do this, so we use a very large number instead, such as 10 to the power 99. The probability that the variable is more than this value is effectively 0, so our results will be accurate. Using technology, the probability is about 0.309. In part C, we want to find the probability that x is less than 26. Again, this is not a whole number of standard deviations from the mean. We set the upper bound to 26. We want the lower bound to be negative and infinite, so we use a very large negative number, such as minus 10 to the power 99. We do not use 0 as the lower bound, even in situations where it is physically impossible for the variable we are studying to be negative. Using technology, the probability is about 0.081.
Okay? Now, with this, I want you to do the following in your notebook. Yeah, Ethan and I were just talking about greater than or equal to. I think that's explained that, even though this is already what you've done. So, can you try question 1 and 2A? Don't do anything without technology. Let's use calculator for everything. So, of course, write your days, write activity or whatever you need to write. Do whatever you do in your notebook. So, try question 1. Let's just get familiar with how to use the calculator. I want us to do question 1 to 4. Yeah.
What exercise is this?
Can I send the screenshot?
Oh, yes, please.
So it's exercise 28D2. Do I send the screenshot to WeChat or just leave it on the board?
Can you send this one?
WeChat, okay. Because we probably work at different pace, so we don't want to hold each other back. One another in this case. Okay, 1 and 2 are sent. Now 3, 4, 5 sent as well. So just try to do question 1 to 4.
Lower bound 60, upper bound 60.
So after this, we go to Z score.
Low.
Low 62, high 67.
I will play an example
Lower
after
bound
this,
64.
which will help you to do questions 9 and 10 later.
9 to the power, or 10 to the power of. For about 60. Lower bound, same, from down 61.
Đánh điểm có thấp. Đánh điểm có thấp. Sao đánh điểm có thấp?
57.5.
Upper or top or lower?
Lower.
Upper.
62.5.
0.3.
Mean 37. Lower bound 40.
Upper bound.
10 power.
0.33. Without technology.
Almost done?
Without technology. Oh, I know. That's what I thought.
Go ahead.
Yeah.
Let me bring a small calculator.
Yeah, you're correct. You're correct.
3. Sit down, y'all.
Yes, sir.
We're taking a 5 minutes break.
Okay. Yeah, before this, of course. If you are done, please take a break. Maybe Miss B can. Okay, but I want to play this. I want to be part of the first video. So can we play this? Then we can take a break. Then go to standard normal. Please be careful. Uh-oh. Brandy didn't get enough sleep today. It's obvious. Is everything okay?
Yes.
He didn't get enough sleep.
Oh.
I actually did not get enough.
Yeah. So what number are you guys?
I woke up at
I'm on
4.
3.
3. And you want a break, lazy boy. Okay, so can we play this? Then we can go for a break. And you can take your time later to complete the rest. Everyone, please pay attention. So this is an example, a word problem. So basically, this involves 2 different random variables. And let's just listen.
In this example, the times taken for students to complete a puzzle are normally distributed. We are given the mean and standard deviation. In part A, we want to find the probability that a randomly selected student took at least 30 minutes. If x is the time for a student to complete the puzzle, then x is taken straight from the given distribution. X is normally distributed with mean 28.3 minutes and standard deviation 3.6 minutes. 30 minutes is not a whole number of standard deviations from the mean, so we use technology to calculate the probability.
Understand that?
We set the lower bound to 30 and the upper bound to be as large as we can. The probability is about 0.318. Look carefully at part B. Suppose y is the number of students out of 10 who took at least 30 minutes to complete the puzzle. What type of distribution is y? We have 10 independent trials of an experiment, and we consider each trial to be a success if the student completed the puzzle in at least 30 minutes. So, y is a binomial random variable with n equals 10, and from part A, the probability of a success is approximately 0.318. In this case, we want to find the probability that y is less than or equal to 5. We calculate this probability using technology. On some calculator models, we can use the previous answer in our calculations. This allows us to be more exact in our calculations. The probability is approximately 0.938.
You will notice the introduction of a new random variable. Please look closely. The time taken by students to complete a puzzle are normally distributed. There was no indication about how many students are involved. Okay? In number B, out of 10 randomly selected students, now there's a new distribution. The reason why a different random variable was introduced. And because the parameters, the circumstances are also different, as you heard. One is a normal distribution, one follows a binomial distribution. So please take time to introduce a new variable when necessary. Does that make sense? So this will help you in calculating questions 9 and 10 later. Okay, I've also sent that to the WeChat. When we come back from our 5-minute break, we will do the standard number distribution, starting with this investigation. Okay, so let's go for break.